All right, chemistry. We're looking at chapter 14, which is all about acids and bases. And we're going to walk through chapter 14 together and talk a little bit about the main topics and then help you with some of the problems here. In chapter 14, we are mentioning acids and bases, and then we'll continue that in chapter 15 as we continue our discussion about it, okay? So you need to definitely look back in your interactive reader and look at the properties of acids and bases. Some of them, the properties for acids and bases are the same for both of them. Like, for example, they turn pH paper, they dissociate in water lots of times. So you need to learn about the different properties and make sure you review those. An Arrhenius acid or base, you have to know how an Arrhenius acid or base is defined. An acid, according to Arrhenius, is one that produces or increases the concentration of the hydronium ion. And a base is something that when you put it into water, this is always in water, by the way, it is increasing the concentration of the hydroxide ion. Okay? And I will also mention here that you need to think about the definition for Bronsted-Lowry acid and base. Bronsted-Lowry, an acid, is one that donates the H+, and the base is one that accepts the H+. Okay? So that's another way to look at it. So Bronsted-Lowry is a little broader than the definition according to Arrhenius. Okay? We'll walk through these and see how they play out in different reactions as we talk about this chapter. Okay? A neutralization of acid and base. You need to know when you take an acid and base, you put them together in a reaction, they will always form a salt, meaning any ionic, some ionic compound, and water. All right? Weak, strong acids, bases, you don't need to memorize them. You just need to know that by definition, a strong acid or a strong base, what we mean by that is it completely dissociates. When you take sodium hydroxide and you put it into water, you will create the sodium ion and the hydroxide ion. It is a complete dissociation, meaning when you put this in water, you will not have any more of the solid left, you will only have ions. Whereas a weak acid or base, for example, that weak acid, you put this solid into water and it will create ions to a certain extent, but you'll still have some of the solid dissolved in the water as well. Not all of it will dissociate. Okay? Conjugate acids and acid-base pairs, that simply means that when you have on one side an acid and a base, on the other side the acid will turn into a base, so one direction, and then acid and base. So for example, the acid, when it donates the H+ to the base, it then will turn into a base on this side. And the base, when it accepts the H+ from the acid, will turn into an acid on this side. So in going the forward direction, this acid and base are going to react, and they're going to form on the other side an acid and base, because if the reverse reaction kicked in, this acid, if the reverse reaction kicked in, this would be donating the H+ back to the base and reform your reactants. So both directions you can look at an acid and base. And when you pair them up, the acid on this side turns into the base on the other side, and the base on the reactant side turns into the acid on the product side. Those are called your acid-base conjugate pairs. Okay? All right. So there's not a lot of calculations that go on here. You just need to know a lot of definitions for chapter 14. So I would encourage you to look back at the interactive reader and review, refresh, and ask questions.